Hi, I'm Suzanne. Video Series 1 is an introduction to the Arizona K-12 Computer Science Standards. Video 3 will introduce you to the computer science practices, including computational thinking. Be sure to also watch Video Series 2 and Video Series 3. These will take a deeper dive into the computer science essential concepts and integrating computer science into all content areas. Today's goals are to begin understanding the computer science practices and computational thinking. The computer science standards support these practices. Math practices describe specific student behaviors to help students develop an understanding of math and empower them to think mathematically. Science and engineering practices help students focus on what they do to make sense of phenomena in the world. Computer science includes 7 practices that describe the behaviors and ways of thinking that computationally literate students use to engage with the core concepts of computer science and fully participate in today's data-rich and interconnected world. The 7 computer science practices are fostering an inclusive computing culture, collaborating around computing, recognizing and defining computational problems, developing and using abstraction, creating computational artifacts, testing and refining computational artifacts, and communicating about computing. This graphic illustrates the intersection between the practices in computer science, science and engineering, and mathematics and how they complement each other. At the end of each standard will be listed the practices that most closely apply to that standard. You will notice that the practice listed has a numerical value behind it. That value shows that developing and using abstractions is practice number 4, and sub-practice number 4 is also being referenced. Appendix B in the Arizona Computer Science Standards document has a complete list of the practices and their sub-practices. The 7 core practices of computer science describe the behaviors and ways of thinking that computationally literate students use to fully engage in today's data-rich and interconnected world. The practices naturally integrate with one another and contain language that intentionally overlaps. The concepts and practices fit together to create meaningful computer science experiences for all learners. In addition to describing the progression of the standards, the narratives within the standards also provide some examples of the interrelatedness of the practice statements and the ways in which these statements build upon one another. This model, used to describe the practices, displays them in an order that shows a process for developing computational artifacts. The display is cyclical. It shows that while each artifact should take all 7 of the practices into consideration, other paths can also be taken. As you look at the graphic, notice that it begins at the very top with recognizing diverse users and valuing others' perspectives, and ends with communicating the results of what learners have done or created to broad audiences. Computational thinking is at the heart of the computer science practices and is delineated by practices 3 through 6. Practices 1, 2, and 7 are independent general practices in computer science that complement computational thinking. Computational thinking is defined as the thought processes involved in expressing solutions as computational steps or algorithms that can be carried out by a computer. A step-by-step problem-solving process. Simply said, computational thinking is taking big problems and breaking them down into smaller problems and solving them. Computational thinking is vital. Students can use it not only in computer science, but in all aspects of learning. By the end of 12th grade, computer science literate students should understand the capabilities of computers, formulating problems to be addressed by a computer, and designing algorithms that a computer can execute. Computer science is the most logical vehicle to develop computational thinking. However, simply using a computer does not mean you are using computational thinking. For example, a student entering data into a spreadsheet is a student using a computer, not a student using computational thinking. On the other hand, a student creating an algorithm to automate how that data is used would be. Thank you. Remember that the K-12 Arizona Computer Science Standards were designed to support the computer science practices for students.